Multiplying and dividing integers. Page 12. Multiplying and dividing integers. Page 12 of your notebook. All right, so we're going to start out with the basics. There are no rules like addition or subtraction where we change the problem. All right, there's no rule like that. You're just doing regular old math. So really, what we want to talk about is right now we can forget the signs. We can forget about the signs. Just do the math. We'll go back and put the signs in later. So when we're doing these problems today, just do the math. You're either going to multiply or you're going to divide. Whatever it tells you to do, that's what you're going to do. And the good news is the numbers that we're working with are not going to be so big you can't do them without a calculator. For example, we may have the problem 4 times negative 3. To begin with, before we do anything else, I just want to do the math. I just want to do 4 times 3. And 4 times 3 is 12. Right now, don't worry about the sign. We'll talk about that in a minute. I just want to do the math. You may have the problem negative 20 divided by negative 5. Again, right now, forget the signs. Just do the math. We'd do 20 divided by 5. 20 divided by 5 is 4. Just do the math. Let's do another one. Negative 3 squared. Forget the sign, just do the math. That means 3 times 3. Three times 3 is 9. Yes, ma'am.
So are we not putting in the negative sign or positive sign anywhere?
Right now, no. Right now I'm going to show you multiple ways of doing it. Okay, and the reason we're just doing the math, right, is because there are so many different ways of explaining multiplying and dividing integers. And if you get home and your parents come up with a different way, or they tell you the way that they learned it and that makes more sense to you, go for it. I'm going to show you a few ways. If there's another way that works better for you, rock and roll. Okay? So, here are some strategies. Forgot my G. Strategies. Strategy number 1. Strategy number 1 is the way my brain processed it when I learned it originally. I learned it that a positive times a positive, duh, is a positive. I learned that a negative times a negative is a positive. And here's why. This is how my mind made it work. I looked and I saw, oh, you know what? This and this, there are two lines, and a plus sign is made up of two lines. So if there are two lines by themselves, I can form them, my mind and my brain, right? I could pick them up and I could turn them and make them into a positive. And then that continued to a negative times a positive. Well, does this guy have anybody to belong to? Can it join up with anybody else? No, that already has a buddy. So I have to put one over here to balance it out. Now it has a buddy to join up to. See, these two buddies joined up right here. Nothing's lonely here. These two are lonely, so they made a positive. This guy was lonely, so I had to put another negative so it would have a buddy. Same thing if it was a positive times a negative. This guy has a buddy with it, but this one doesn't, so my answer is going to have to be its buddy. That's strategy number one. That's how my brain processed it. Strategy number two is kind of the good guy, bad guy. Good cop, bad cop, right? Except it kind of makes you depressed about the world, so I don't like this one as much. But if that's the way your brain works, that's the way your brain works. So if there are two good guys together, good things happen. Right? If two good guys do something, it's a good thing. This is kind of the weird part. If there are two bad guys, if two bad guys get caught, that's a good thing. And if there's a bad guy and a good guy, that's bad. If a bad guy and a good guy get taken in, that's a bad thing. And a good guy and a bad guy get taken in, that's a bad thing. So, I mean, I get it. You can make arguments like double negatives, two negatives make a positive. Well, not really, but I mean, if that's how you explain it to yourself, I can get it. That's not my favorite. But look, it's the same thing, right? Number 3. The downfall with number 3 is that you have to draw this triangle the same way every time. If you mix up and put a positive down here, it doesn't work. But here's how I remember it. Positive is a bigger number, right? So it's up top. And down below, lower, are the negatives. You put the positive up top and 2 negatives on the bottom. Well, a positive times a positive is a positive. You don't need any help with that. Down here, if you had a negative times a negative, you'd cover up a negative times a negative, and what's left over? A positive, so your answer's positive. If you had a negative times a positive, let's cover up a negative, and let's cover up a positive. What's left showing? A negative, so your answer is negative. If you had a positive times a negative, what's left showing? A negative, so your answer is negative. So to use this, you cover the signs in the problem. What's left is the answer. So let's go back up here to our original problems. 4 times negative 3. Depending on which one you want to use, right? The signs have to have a buddy. The good guys and bad guys. I mean, I know these look the same. Or the triangle. It's your choice. 4 times negative 3. We know 4 times 3 is 12. Is my solution positive or negative? 4 times negative 3. Haley? Negative. 4 times negative 3. What's left uncovered? Negative. So my answer is negative 12. Negative 20 divided by negative 5. You can think, okay, 2 negatives make a positive. Or you can go down here to the triangle and a negative. What's left uncovered? Positive. Or you could think if 2 bad guys get arrested, that's a good thing. Positive 4. Down here, negative 3 squared. That means negative 3 times negative 3. How many negatives are there? 2, so you can cover up 2 negatives and get a positive. You can think 2 negatives, 2 bad things make a positive. You can think the 2 signs form together to create a positive. However your brain works. The last strategy I want to show you is the best strategy for problems that have more than 2 numbers. The last strategy is if there's an even number of negatives, it's a positive answer. If there are an even number of negatives, 2, 4, 6, 8, 10, hopefully there's not 10 negatives. If it's an odd number of negatives, the answer is negative. Even is positive. Odd, negative. So if I look, is there an even or an odd number of negatives? How many negatives are there? 1. Is that even or odd? So my answer is negative. How many negatives are in this problem? 2, which is an even number. So it's positive. How many are up here? 2, because it's negative 3 times negative 3. 2 is an even number, so my answer is, for example, what if I gave you this? Negative 1 times 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 negative 1.
It's a negative.
Right? I mean, that's a big problem. I can forget the signs. 1 times 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 1 is 1. That was easy. And then I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is odd. So my answer is negative. If I gave you the problem 2 times negative 3 times negative 1 times negative 1 times negative 1 times negative 10 times 1. Forget the signs. What's 2 times 3? 6 times 1 times 1 times 1 times 10, 60 times 1, 60. And then I'm going to count the negatives. 1, 2, 3, 4, 5 is odd, so my answer is negative. Questions? Comments? Concerns? This, that, and the other? All right.